Welcome back, everybody. In this next lesson, we're going to talk about another specific set of polygons, trapezoids and kites. Okay, objective to use the properties of trapezoids and kites. We'll define those for you, we'll give you some properties, and we'll do some solving for angles and side lengths, pretty similar to what we've done with other polygons so far in this chapter. Alright, here we go with trapezoids and kites. Alright, so first off, what is a trapezoid? I'm going to say a trapezoid is a quadrilateral, so a four-sided shape, with exactly one pair of parallel sides. Okay, so four-sided shape with one pair of parallel sides. Now, I didn't put a picture of this in the note guide for you because I kind of like to have you draw the picture based on the definition. It's a good way to really make sure you understand that definition and what it means. So let's draw a trapezoid. I'm going to make one pair of parallel sides, like so. Okay, not very nice looking lines, but we can mark them as parallel with some arrows. And the key for this is I can't also make them congruent to each other. I can't make them the same length. We gave you a theorem a few sections ago that said if you have a quadrilateral where one pair of opposite sides is both parallel and congruent, then you know you have a parallelogram. Alright, so those two parallel sides have to be different lengths. And if I connect the sides together with additional sides, we get a trapezoid, okay, a quadrilateral with one pair of parallel sides. Okay, a little bonus vocab we'll use for you. Usually we call the parallel sides the bases. So I'd say I have a base on top and a base on bottom. And then we'll say the other sides are the legs. So I have two bases, two legs. That's usually how we refer to the sides of a trapezoid. Alright, now based on that definition, we can start solving for parts of the trapezoid. We can start solving for angles. So let's see here. Problem 1 says find the value of A and B in the trapezoid. It looks like I'm given 2 out of the 4 angles. I want to find the other 2. And here's how we can do that. I'm going to mark this picture up. You don't need to do the same thing. But to make this look a little more familiar, I'm going to extend my parallel sides out and one of the legs to make my picture look more like I had back in chapter 3 where I had parallel lines and a transversal. Okay, now as far as parallel lines and transversal goes, we'd say that this angle A and the 43 are same side interior angles. And back in chapter 3 we said that if the lines are parallel with the transversal, same side interior angles are supplementary or add to 180. Okay, we're going to approach this trapezoid problem basically the same way. So let me get rid of the extra lines I've got here. So again, the A, the 43 are essentially same side interior angles. We know they're supplementary to each other. They'll add to 180. So what I can do to find A then is I can say A is equal to 180 minus the 43, which would give us 37 degrees for A. Okay, I can do the same thing on the other side of the trapezoid. The 121 and the B will be supplementary as well. So I can say that B is equal to 180 once again minus 121, which would give us a 59 degrees. Alright, so using those supplementary properties, I can always solve for at least one of the other angles of a trapezoid. Next thing we're going to talk about is a specific type of trapezoid called an isosceles trapezoid. Now we've seen the word isosceles before with isosceles triangles. That was a triangle where 2 of the sides were congruent, and we call those 2 sides the legs. Well, an isosceles trapezoid is basically going to be the same thing. We'll say it's a trapezoid where the 2 legs are congruent. So if I want to draw an isosceles trapezoid, what I'd do is I'd make my 2 parallel bases. And then I draw them in such a way, I'd lay them out in such a way where the 2 legs, the non-parallel sides, are congruent to each other. Okay, so that's how we'd construct a isosceles trapezoid. Alright, then we have one property specific to isosceles trapezoids, okay, or one theorem about them. I'm going to say that if a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. Okay, so if we have our isosceles trapezoid where the 2 legs are marked congruent, Okay, then the base angles, the angles that share a base, as in T and P here, will be congruent to each other. All right, same thing with R and A. That's my other set of base angles. The other two angles that share a base, we'll say they're congruent as well. All right, let's go ahead and use that property here. Problem 1, part A says that CDEF is an isosceles trapezoid, and it's marked as such with the legs marked congruent here. And we're given the measure of angle C is 65. We want to know what are the measures of angles D, E, and F. So in other words, we want to find the rest of the angles on this trapezoid. Okay, so we want to find angle D, angle E, and angle F. All right, now I can basically start this problem by finding any angle I want. Okay, the order is not necessarily going to matter for this one. Let's start off by using that property right away, that isosceles trapezoid property. We said that base angles are congruent. So I could say that C and F are a set of base angles since they share this bottom base. So we know they'll be congruent to each other, meaning that angle F is just 65 degrees. Okay? As far as finding the other angles, let's go with angle D next. Now, just like in the first trapezoid problem, the angles across from each other on opposite bases are going to be supplementary. So C and D will add to 180. And again, that's because my bases are parallel. So for D, what I'll do is I'll say I have 180 minus 65, which will give us a 115 degrees. All right, for my last angle E then, we could say it's supplementary with F, or since D and E are base angles on the same base, we know they'll be congruent as well. So E is just going to be the same as D, the 115. All right, there's an example of solving for angles in an isosceles trapezoid. Part B is the same thing. Why don't you take a couple minutes, give part B a shot, and then hit play to run through that to check your answer. All right, so part B, same idea. We've got an isosceles trapezoid. We want to figure out the measure of angle P, the measure of angle Q, and the measure of angle S. Okay, we can start with any angle we want. I'm going to go with S first because R and S are base angles. We know they'll be congruent. So S is just 106 along with R. Next I'm going to find Q. Q and R are on opposite bases. Same side of the trapezoid, therefore they'll be supplementary. They'll add to 180. So to get Q, I'll go 180 minus the 106, which will give me a 74 degrees. And then for P, Q and P are base angles as well on the same parallel line. They'll be congruent. So P is the same as Q. In other words, P is 74 degrees as well. All right, the other type of polygon we're going to talk about today is a kite. We're going to say a kite is a quadrilateral with two pairs of consecutive sides congruent and no opposite sides congruent. Okay, so let's use that definition to draw a kite, just like we did with the trapezoid. When I say that consecutive sides are congruent, that just means that sides that are next to each other are congruent. So what I have here is an example of consecutive sides congruent. We'll say those are the same size. And the kite has two pairs of those, and no opposite sides congruent, meaning that I need to make my other set of sides of different length. And we can mark them congruent to each other, but not to the opposite sides. Okay, if opposite sides were congruent, we'd have a parallelogram. That was a theorem we had. Quadrilateral or opposite sides are congruent is a parallelogram. All right, and the one property or the one theorem we're going to give you about kites is this. We're going to say if a quadrilateral is a kite, then its diagonals are perpendicular. So if I have a kite and I draw the diagonals out, they'll be perpendicular to each other. In other words, intersect at a right angle. very similar to what we had with a rhombus, and we'll answer some similar questions about angles for kites. So let's put that property to use. Problem 3, part A says quadrilateral DEFG is a kite. What are the measures of angles 1, 2, and 3? So similar to our rhombus questions, we know one of the angles. We want to figure out some other ones formed by the diagonals. So we want to know angle 1, angle 2, and angle 3. Okay, with this one I'm going to start off with where the diagonals come together, angle 1. The property we just gave you said that the diagonals of a kite are perpendicular, therefore angle 1 is 90 degrees. And once I have that, I can find my other angles. I'm going to go with angle 2 next. To do that, I'm going to break this figure down into a set of triangles. Okay, angle 2 is an angle in that triangle. We know the other two angles. So what I can do for angle 2 is I can say we start off with 180 for the total sum of the interior angle of all triangles, and subtract the angles I know, so minus 90, minus 52, which will give me a 38 degrees for angle 2. All right, finally angle 3 then. 3 is going to be congruent with this 52 here. Okay, so 3 is just 52 degrees. And the reason I know that is these top two triangles are going to be congruent triangles because we're talking about a kite, so they'll have congruent hypotenuses. They share a side here that's congruent. They have the same right angle. Okay, therefore they are congruent triangles, and those corresponding pieces will match up. They'll be congruent to each other as well. All right, so that's how you find angles in a kite. Problem B is the same idea. Why don't you take a minute, pause the video, work through that one, and then hit play to check your answers. So in part B, once again, we want to find the missing angles of the kite. Here we want to find angle 1, angle 2, angle 3, angle 4, and angle 5. Okay, so a few extra angles for this one. I'd say start with 1. 1 is where my diagonals come together, so 1 is just going to be 90 degrees. Okay, once I have 1, I can find 2 by, again, breaking this kite down into smaller triangles. For this triangle in the upper left, I know 2 out of the 3 angles. So for angle 2, we can say we have 180 minus the 90 again, minus the 38, which will give me a 52 degrees. And then moving on, 3 and my 38 will be congruent to each other because on the left side I have 2 congruent triangles on top and bottom, so corresponding parts will be congruent. So 3's 38 as well. Next we can do angle 4. For angle 4, I'm going to split this into another triangle. All right, I know I have a right angle and a 53-degree angle. So for angle 4, I'll take 180 minus 90 minus 53, which will give me a 37 degrees. Okay, and notice angles 2 and angle 4 are not congruent to each other. That's because these two triangles on the top are not congruent. They have different hypotenuses. It's the 2 on the right side will be congruent. And using that, I know that these last 2 angles, the 53 and the angle 5, are congruent to each other. Therefore, angle 5 is just 53 degrees. All right, so that's it for trapezoids and kites. You can start getting some practice in, cranking out the homework. Let us know if you get stuck anywhere or need any help, and we'll see you folks next time.